and welcome back to CSEN. Today it's our second video on information gathering series that we are going to give an introduction on Amap tool, right? So without wasting our time, let's get started. Let's dive into this whole thing. So before getting started, we will see what today's agenda is. So today's agenda, we will talk about what is Amap and what is a handshake or handshaking protocol and how it works. Then we will look into the full duplex mode methodology and the working. Then half duplex and the TDM, that is time dimension multiplexing or operations, and also the T1 lines. Also, we will look into the tools included in the Amap package and the RPC services protocol or the RPC protocol and how it works. And last but not least, we will look into Amap features. So, what is Amap? Now, Amap is nothing but it's a application mapping scanning tool. Now, Amap is designed to correlate the applications that dwell on a host to premise port to port. Now, Amap equates it to the ports and sends packages that will automatically counter in rejoinder. Now, also this package typically involve a standard attempt by an application to perform a handshake between those both hosts, right? And many network demands counter only when an attachment is attempted utilizing a relevant handshake, that is SSL. And now Amap also then composes this acknowledgment on its built-in library and cover. That's all about the Amap. Now let's move ahead and we're gonna see about what is a handshaking or a handshaking protocol, right? Now, handshaking is the method that builds the communication between two networking devices. For instance, or for example, when two computers or two machines first combine through modems, the handshaking process or the plots, which the protocol speeds, condensation, and error correction systems will be using the different communication sessions, right? Now, the handshaking is also specified at the start of each concourse because typically the modems differ in their merchant, the design, the hardware and the software configurations. And now the handshake is also guaranteed, or it will give the guarantee that the conversation is possibly despite will be different, right? Now let's see how it works. Well, the handshake working methodology is like that, how during the handshaking process, both the modems send a series of control flags and counter to each other signals. The handshaking is also referred to as a flow controller. Now, because it's the method establishes that the spot rules for governing the flow of the control between the two devices, some of the parameters that the modems need to transmit are: the number one is that the maximum transmission speed, taking into consideration the speed of the both modems and the quality of the transmission. The second is that the length of the line delay to apply the echo cancellation, and the third one is that the communication protocol. The modern modems like the RS-232 will transmit the control signals in the full duplex mode with over the RS-232 or 233 interface that connects them to the computers. As I mentioned here, what is full duplex mode, right? Let's see about what is full duplex mode. Now, here we're gonna see about the full duplex mode. Full duplex mode is nothing but it's a mode of the transmission in which the data is concurrently forwarded and received between the stations. Full duplex communication is twice as fast as half duplex communication and typically uses the separate pairs of wires or two channels for wireless networking for supporting the simultaneously transmission and reception by a host. Right now, alternatively, there is an arrangement is to use some multiplexing techniques such as the TDM or the time dimension multiplexing to interleave transmission and reception on a single channel. This does not produce true full duplex communication, but to an ordinary user, it might appear to do so if the interleaving process is fast, ample, right? Now, as you can see here in the screen, we have some kind of simplex, half duplex, and the full duplex. Now, simplex is nothing but it's a very kind of one-way transmission only. And in the half duplex, we have the reverse kind of alternatives, like the reverse kind of communication will be there, like forward alternatives with the reverse. And in the full duplex, as you can see, it's very fast. Like it will simultaneously do the sending packets and receiving the packets. In the full duplex mode, it's a very fast, like 2x fast, and as compared to the half duplex, right? Now let's see about what is a half duplex communication. It's a mode of transmission in which the data can be transmitted or received, but cannot be sent and received simultaneously. Now the easiest example or the instant example is that we gonna take a walkie-talkie. Like we have to press a button to talk and we have to release the button to listen. When two people uses the walkie-talkie to communicate, at any given moment only one of them can talk while the other listens. If both try to talk concurrently, a collision occurs or the dilemma will occur and neither will hear what the other says. Like that one is very true. Now, like the communication through the traditional Ethernet networks is another example of the half duplex communication. Now, like when one station or one network on an Ethernet sends and the other station identify the carrier signal and listen instead of communicating, right? If two stations transmit the signal concurrently, there will be a dilemma or there will be a collision occurs and both stations stop the transmitting the data and wait for the random intervals of time before retransmitting. Now, the examples of full duplex communication include the cellular telephone technologies and the full duplex Ethernet, and also the examples of the half duplex communications are the walkie-talkie, the CB radios, and standard Ethernet networks. And as I like to give example of simplex communication technology, which will include the satellites broadcasting and the cable TV broadcasting, right? So this was whole about the full duplex mode and the half duplex communication, right? So let's get moving into the next slide. Let's see what we have in the next slide. Well, here we have TDM, the time dimension multiplexing. Now, time division multiplexing and dimension multiplexing, or a TDM, simply a TDM, is a multiplexing approach, right, to dispatching the multiple data streams in a single transmission path. Now, how it works, how TDM works, right? Let's see. Now, here the TDM, the time division multiplexing or dimension multiplexing, it's the data, where the data from a distinct or a different input, it courses is partitioned into like a fixed length portions and then consolidated in a round robin fashion into a unique output data stream, which can be then be dispatched over the individual channel transportation system and demultiplexed at the target location, right? Now here the fragments can be created by the multiplexer itself, or it can be inherited or integrated into the input channels, such as the fixed length frames. Now, for instance, let's look into this example. Here in the screen we have if the input streams like A, B and C are divided into the segments as I shown here. Now we will get the output like this. The output stream will look like this here in the screen as I shown here. Now here will be a kind of problem will occur, like there will be one fault in this mechanism, is that if an information channel does not have anything important to carry for a time, or it is an empty segment were inserted into the output stream anyway. For example, if channel A is not transmitting the data, 1/3 of the output channel is not being used, you can overcome this weakness or this vulnerability by using a more sophisticated multiplexing technique called statistical multiplexing, right? Now let's get into next slide. We will look into this TDM. TDM is also used in the T1 lines, and as I shown here, TDM is used in T1 lines to enable them to simultaneously carry 24 data channels by interleaving data into portions of a single 193-bit frame. Like for example, bits 1 through 8 will represent the channel 1, right? And the bits 9 through 16 represents the channel 2 as I shown here, right? And so on. The bits 185 through 192 will be a channel from 24 plus bit 193 for synchronization. And this framing process occurs 8,000 times per second. That's a huge. And it will produce a total throughput of like 1.544 megabytes per second, right? Now this was about the T1 lines in the TDM. Let's get moving into next slide. We'll see what we'll have in the next slide. Well, in the next slide we have the tools included in the Amap package. Right now, the tools included in this are the Amap graph and Amap application mapper. Now, Amap graph is a tool which sends the random data to a UDP or TCP or SSL port to encrypt an acknowledgement. An Amap application mapper is the next and generation scanning mechanism or the tool for the pen testers. Now let's get into next slide and we'll see about the command line attributes. Now the first usage of the Amap are the, as you can see how it is there, like we have the small -f which will export the data into the files, and the small hyphen G, which will output the results via the GUI, the interface. And the options will include in this Amap or the Amap, and will the options as you can see here, and the map file name, right? This was about the Amap. And now here we will look into this slide, the Amap graph usage. As you can see in the root Kali, as we can initiate the Amap graph, there will be a syntax like Amap graph. In brackets we will have hyphen capital S, which will use the SSL after the TCP connect, and it will be not usable with the small u, which is a UDP protocol, right? And the default will be TCP. This will be not usable for the C, which is a concurrent, right? And the small hyphen N, which will connect the maximum number of the connects, and the default will be unlimited, right? And we have another N, small hyphen N, which will delay the between the connections in the MS, which will be the default 0 port. And we also have the small hyphen W, which will delay before the closing the port, and the default port will be 250. So also we have the verbose mode and the small hyphen E, which will not stop when a response was made by the server. As you can see, the 0AB, which will send has a random graph, and the 0 hyphen, which will null bytes. A small hyphen will be letters plus spaces, and the B will be binary. Now, as you can see here, right, in the very bottom, it has written that this tool sends the random data to a silent port to initiate a response, which can then be used or utilized within a Amap for future detection, right? For future identification. It whether the output will be a proper Amap app definitions. So this is how the Amap graph will usage, and next we have the Amap application mapper usage. So in the root Kali we will see here as we initiate the Amap, the application mapper usage. We can see the syntax will be the Amap, and we have the small hyphen and a capital A, which are the map applications, which will send the triggers and analyze the responses, and it will be very default. By default, it will be like that only. And we also have the small hyphen, capital B. It will just grab the banners, do not send the triggers. And we also have the small hyphen P, which are the no banner or application stuff. It is a very fully connected port scanners, and the options will be included in this are the small hyphen 1, the 6, and the small hyphen B. The 1 will only send the triggers to a port until the first identification. It is very speed, okay? It is very speedable in this. And the 6, the small hyphen 6 will use the IPv5 instead of IPv4 protocols. And small hyphen B will print the SF banner for the responses only. As you can see in the very bottom, it has written that the target port, the target address, and the ports to scan additional to hyphen I. The Amap is a tool to identify the application protocols on target ports. Now, this is the version which is not compiled with the SSL support also. And here they had given the usage hints. The option of hyphen BQV are very recommended, and it will add the hyphen 1 for fast and rust checks in the network. And as you all know about this small hyphen D small d, it will dump all the responses, like it will dump whatever the vulnerability or the applications or the information is there in the network. It will dump all the informations. And there is verbose mode also. The both will be same, but it will use the twice of the mode for debug, which is not recommended, right? And we also have the hyphen capital C, which will retrieve the number of the reconnects on connection timeouts, and it will see the timeout also, and the default will be port 3, right? So this was all about the Amap. And one more is there is a small P hyphen P, which will protocol, which are the protocols only send the triggers for this protocol, like for the FTP protocol only. So this is all about the Amap application mapper usage, right? And next we will look into, lastly we have to look into the features. Sorry, not features, it's about the RPC service protocol. Now let's look into the RPC service protocol. Now RPC is nothing but it's a remote to procedure call, and is a protocol for developing the appropriate frameworks. Typically it authorizes a program on one device to sell or to call a subroutine on a different machine or a different device without understanding that it is a remote device, right? Now RPC isn't a vehicle convention, rather it is a strategy for utilizing the existing interchanges, includes in a straightforward manner. Now this straightforwardness is one for the very ridiculous like characteristics or the features of the RPC protocol has a device. Now since the application programming doesn't include any communication code, it is self-governing of like the specific communication equipment and the perspective, the utilized, and also there is a working framework will be utilized, and the calling system is very pre-resumed, or it will be very resumed to utilize the necessary correspondence of the programming, right? So this was the whole about the RPC service protocol. And now let's dive into next slide. We have the Amap features. Now the top 3 features of the very aggressive features of the Amap is that it will group by the module, by catalog, and by the session or the section, and by memory configuration, which will be GCC. And the second one is that it will search the substrings and code line contentions. And the third most top feature is that it can be used as a command line tool, and although it is yet a GUI application, right? Now other features which will include like it will distributing by the caravans, and it is a wholly outline. There will be a drag and drop, and also it's a very freeware, right? There will be no spiral, like things will be there in the Amap, and it's similar to Hydra, right? And as also it will work on the Windows in Mac OS X version also. So this was all about the Amap features, right? So hope you all love this session. I hope we will get through this. No, thank you all for watching this session. Well, today we'll look into this thing, right? We had looked into this thing, this Amap, and hope you all love this session. After that, we will We'll come up with more sessions in CSEN. Stay tuned, stay updated. Please hit the like button and subscribe our channel CSEN. Follow us socially on Twitter, Facebook and Instagram. Thank you.